Hello, so today we are doing this problem called maximum length of concatenated string with unique characters. So the problem says we get an array and string s, which is a concatenation of a subsequence of array that has unique characters, and the goal is to return the maximum possible length of this subsequence s. And so to see an example here, we have an array that has un, eq, and ue, and all the possible concatenations don't have duplicate characters, that have only unique characters, are the empty string, the first one, the second string, the third string, a combination of the first and the second, or a combination of the second and the last, right? And the longest ones are this one, and they are both of length 4. So take all the concatenation of the subsequences of the array and take the longest length of the one that doesn't have any repeated characters, only unique characters, right? Same thing for this example. The longest ones that don't have repeating characters are this one, which is a combination of this, and this one, which is a combination of this and this. Okay, so let's see how we can solve this problem. So let's see how we can solve this problem. So first, let's take the first example that we have here, which is so we get an array like this where we have these words, and the goal here is to get the subsequence of this array. So what we want is subsequence as a string, as a concatenated string, with only with unique characters. We shouldn't have any duplicates. So that's what we are looking for, and what we want here is the result, or the goal of this function is to return the maximum length. So let's call this so this here subsequence of concatenated string with unique characters. So these, let's call them s, are the subsequences of these arrays. So for example, it can be taken this one and this one, which would give us un, ue, but this one has duplicate characters, so we shouldn't include this one. But we can, for example, instead of taking these two, we can maybe take, let's say, this one, and that would give us a combination like this one, and that's a valid one, so that's one we should keep. We also have this other combination subsequence that we can take, which is pretty much this one, and that one is unique, and this one we can take this one. And so from these subsequence, let's call these s. So these we need to take the length of the maximum length one. So basically the goal here of the function is to return the maximum possible length. So in this example, the maximum possible length is 4 actually, because we have 2 and they have the same length. So the output for example 1 should be 4, right? If we take another example that we have in the second use case, which is this array with act and this, right? So for this one, we can't take this one with this one because we have duplicate r's. We can't take this one with this one because we have duplicate a's. And so the combinations that we can take, or the subsequences that we will end up able to take, are just this one, right? Which is this one and this one, or we can take this one and this one basically and the last one, which will give us this, or we could take this one and this one, which would give us this. So this is the set S, and the longer one is this one or this one. Both have length 6, and so our output should be 6. And so you could see here, just from doing it by hand, what did we do? The first thing we did was generating all the valid subsequences, right? Generating all valid subsequences and then concatenating them, and or like maybe not then, maybe while generating them we can just concatenate. And so and then, or maybe not then, but we concatenate and then take the longest one, and that's basically and output the length, right? And in this case here, what all valid means is that it has no duplicate characters. And so whenever you see something that asks us to generate all subsequences, maybe with some constraint, but still when it asks us to generate all constraint, you need to think about either like doing some kind of DFS or some kind of backtracking, right? And this problem, if you look at it, it's some kind of combinations of these strings, right? But the order doesn't matter, right? Because if this one here, we could write it as this, but we could also write it as this, but the length would be still the same, so no need to generate both, right? And so one thing we can deduce is that order doesn't matter, right? And so when order doesn't matter, it's not really like a permutation kind of problem, it's more like a combination. So and when you study backtracking, the first examples that you learn are combinations and permutations and how to generate this. And so that's what we are going to use here, is something similar to generating combinations, but with the caveat that it should not have any duplicate characters. I have a video about how to solve backtracking problems with some sort of templates. You could take a look at that first, and that's what I'm going to be applying here. And the general template of that is just the following. It's for every backtracking type of problem, you need to think about when would you have a solution, like you generate all subsequences, but for one possibility, when do you know if it is a solution or not, right? That's one of the questions you need to ask. The second question you need to ask, when you are at some possible step while generating, what are the candidates you need to construct, right? And so these are the most important things that we need to think about. And then after that, you can just apply the template, which first checks if the input, if the solution we generated so far is a solution. If it is, it processes it, which means basically it prints it or it adds it to a list, and then it constructs the candidates using some criteria, and maybe also some constraint, like in our case the constraint is to not have any duplicates, and then go through these candidates one by one and try each one of them, right? And trying each one of them means considering that element, or we could call it making a move using that element, and then backtracking to the next position. And then once you are done, you unmake or you remove the choice that you just made so that you can try another choice, right? And so that's what we will be applying here. So let's see how would that look like. So when do we have a solution? So what is a solution? So basically, whenever we reach the end of the array, right? Because then we have nothing to use anymore, right? So how can we represent this? We can represent it by passing the index of the element we are considering, right? So passing the index of the element we are considering. And then we could just check after that, we could just check index equal to the length of the array. That means we possibly have a solution and we can exit. The other thing is generating the candidates or constructing the candidates. So let's see how we should do that. So here it's very easy because we just have an array, right, of strings. So we have S1, S2, S3, right? And so all we need to do is, and we know that we already processed this much, and so we are at this index. And so let's call this maybe Si, and this is Si plus 1. So all we need to do at this point is check basically if taking this one will cause us to have a duplicate. If it doesn't, then consider that and use it, because we want the maximum length. So anything that won't violate the constraint of unique characters we want to take, right? So basically the candidates would be just for any I starting from index to the length of the array. We just need to check that adding that element won't cause us to violate the constraint. So we can just say if not has duplicates. For what is it that may have duplicate is the string we have so far. So S, let's call this S basically would be the concatenated subsequence we have so far. Subsequence, which basically would mean here when we are at, let's say we are here, then the concatenated string we would have so far is these two, because it doesn't violate any constraint, right? And so and then we could add plus the element at position I, right? And if it doesn't, then let's just take that and do backtrack and go to the next position with that solution. One thing you might notice here is that I'm adding the string here, and this is basically would be the same as if I did it outside, which means, for example, made the move here by doing something like this, and then removing it here, maybe by saying remove from some index, let's say I minus length of array I, or something like that. That would be the same, because I will be adding it and then removing it, but instead I can just pass it as a parameter and not even change S, right? So those two are the same. And this is basically now we have our solution. All we need for backtracking is to know when should we consider something a duplicate, and to when should we consider a solution a partial solution a solution, which means basically it's done, and then the other part is at each step what are the candidates that we should constrain. I strongly recommend you to watch the video about the general backtracking template. They will post in the description, and also the combination problem before if you have difficulty basically understanding this. And yeah, so that's pretty much it. And then at the end we can just while doing every call, basically to be able to return the maximum length, since the problem doesn't ask us for all the subsequence. And so what we are interested in is just the max length. So we could just change this slightly, and then at each step, check if the solution so far is the maximum length, right? And that would be just by doing something like maybe let's say something similar to just basically having some variable that is called maximum length, and just taking the max of that maximum length that we have so far, and the length of the current solution, which let's just call it S, right? So this one would be which are, I said, the concatenated substring subsequence that we have so far. That is of course valid, and we will need also to write this as duplicate function. But the general template is pretty much all of this. So let's just recap a little bit what we did here. So we saw the problem, we thought about it, and we did it by hand, and we saw that, okay, we are generating all the subsequences, and then we are concatenating them, and we have some constraint that we shouldn't have any duplicate characters. Okay, and then we matched this, that the fact that we have a set of solutions that we need to generate, that pretty much matches backtracking. And so we thought about applying backtracking. We know a template to apply backtracking, and we know that we need to answer two questions. When should we consider a partial solution, a full solution that we should add to our set of generated solutions, and at each step, what are the candidates that we should consider? And that's what we defined here with this for loop, and with this checking if it doesn't violate the constraint that we have in the problem, and then doing the backtracking recursive call. And then we need to change a little bit to return what the problem asks, because the problem doesn't ask for all solutions, it asks for the maximum length, and so we need to adjust a little bit for that. So now let's go to Leetcode and just type this solution in detail and see if it passes. Okay, so let's code what we just went through. So what we need first is we need to define our backtrack function, right, that we are going to use. And the parameters for that is the index of the string where we are at, the position where we are at, so that we can know when we have a solution, and S here, which will represent the partial solution, right? So S, partial solution so far. And then we need to, so index, the index where we are at, basically, in array. And we need to start out by calling backtrack with the first index, of course, and we start out with an empty string. And we need to have some kind of maximum length that I'm just going to put as a variable here, and initialize to 0. And then I'm going to initialize that to 0, and then that's what we are going to return, and that's what we are going to input here. And remember, in the explanation we said that we want to do that in every iteration, so that whatever string we have as a partial solution, we can check if it's the maximum length and use that, right? And then we need to check if it's a solution, so that part here, basically the part of the backtracking solution. And so we will need to check if the current index is the last one, so we are done basically. We can either like do this here, right? This is also definitely valid, but I just prefer to do it at every iteration, so it's more clear. And then we generate the candidates, or construct the candidates. And as we said, that would be just going through the loop, similar to what we do when we are generating combinations of an array. And then we stop at the length of the array and check if the solution that we are considering right now doesn't have duplicates, then we take it. And so the solution we are considering is whatever partial solution we have so far plus the element at the current position. And if that is doesn't cause us to have duplicates, then we go to the next position with I plus 1, right? That's the next position, and with the partial solution containing the element. But if the element causes us to have duplicates, we shouldn't continue through with it, right? And that's pretty much it for this backtracking function. The next part is to just handle the case where we have an empty array here. So if we have an empty array, we should just return 0, right? And the other thing is is this has duplicate function. We need to define that so that we just check if a string, let's call it SS, has duplicates. And so for that we can just use Python's counter that just counts how many characters, basically just calculates for each character how many times it occurs in the string. And so we can just go through the values there, and if we encounter any character in that string that has the length bigger than 1, which means it occurs more than 1, that means we have duplicates, so we return true. Otherwise, if we didn't find anything like that, we return false, right? And so we just need here to import the counter. So from collections we can import counter, and that's pretty much all there is to it. So now let's run this. So something is kind of wrong. Yep, so first I need to return true, and this is false, and we check has duplicates. Why is it saying? Oh, sorry, I'm doing length of S actually. So it's when we reach the end of the array, the input, right? When we try all of them and we are at the end, that's where we should consider ourselves done and we have a solution. Okay, so that seems good. Now let's submit this and see if it passes. Okay, so that solution passes. So what is the time complexity for this solution? And so generally for backtracking problems, you need to just look at how many times we call this function, right? And so one thing you can see here is that we start out from position 0, right? So we start out at position 0, and then we have the choices we have are from 1 until the length of the array, right? Choices from 1 to n, the length of the array. And then after that we are at index 1, and then choices there that we will potentially call backtrack if we don't have any duplicates. So for example, if we consider the worst case where the entire array can be concatenated into the maximum length string, which means basically we will enter this if block, right? And so for index 1 the choices are from 2 to n, and at index 2 the choices are from 3 to n. You get the idea basically. So every time the choices diminish, so from 1 to n, then 2 to n, 3 to n, 4 to n, and this is like basically what you have with choose nk thing. And the sum of these, usually the sum of from n0 plus n1 and then until n, that is the formula for that is usually just 2 to the power of n. And so that's the time complexity that we have here, because that's how many calls we will do to backtrack function. In terms of space complexity here, we are also doing this. We are not using any extra thing except this variable, but we are doing the recursive call. So in terms of the space that we will use for the stack, it's exactly also how many times we will call backtrack. So it's similar to the time complexity here. Yeah, so that's it for this solution. Next we'll try to solve this problem using another different okay, so now let's see a different solution. Let's try to solve this with just simple recursion, kind of a brute force way. And the goal from this is to build from there and find a dynamic programming solution. So so what are the choices we have, right, for this, right? For each string, what are the choices we have? So we can just take the string if it doesn't violate the constraint that we should have unique characters, or just leave it. And this choice we can make for every string, right? And this one, it has to be valid in that the string itself is not something like A, B, for example, where itself has duplicate characters. And also, if we have like a previous string, like in the state that we constructed so far, let's say we have DAB, we can't add a string AB because then we'd have duplicates A and B. We can't add AK because then we'd have duplicate A, right? We can't have BC because then we'd have B here, right? But we can add let's say E, for example, right? And so that's the idea. It has to be valid itself, and it has to be valid with the previous string that we constructed so far. So these are the choices. Now, what is the base case? So the base case is that when we have so we have an array, right, of strings S1, S2, and then we are traversing it using our recursion. So I is here and then here. So we stop when I is at the end, right? So our recursion is stops when index is at the end, which is equal to length of the array. And at that point, what should we do? We should just say there is nothing, so their length is just 0, right? And now for the recursion, what are the like smaller state, right? Recursion states. So those are we have two choices, right? Choices are: one, leave the string, right? Leave it. So leave the string and don't take it, and that's easy. At that point, we can just recurse. Let's call it max length recurse. And we will need to call with the whatever we used so far, and then the index, which would be the next index. And so we used whatever we used so far without including the string. Now we need also to discuss how to represent the used so far in an easy way. Used so far. And then we can take it, right? Take the string, but that can be only if it's valid. So first is check if the string is valid, which means it doesn't have a duplicate characters, and the string is just the element at index, right? And string would be valid if it has only different characters. It doesn't have something like this where it has duplicate characters, right? And so if it is, let's put that in a variable, right? So that's one of the conditions. The second condition we said is that it has to be valid with the previous representation, which is used, right? And so for that, we need to check, maybe let's just put a function for now, has no duplicates with, let's call it has no duplicates with used so far, with the characters used so far, right? And let's call that, let's say, has no, or valid with the used. Let's call this one valid with used. And so this needs to be with used and with the array with the string, right? And then once we know that this, we can just check if both are valid. So if it is valid and it's valid with the used so far, which means it has no duplicate characters with what we used so far, then we can call our recursion here and somehow concatenate or union the used so far with the string. So union, we'll see how can we do that later. And then the index, go to the index, so +1. So this means basically taking the string. So that's our recursion. Now let's see how can we represent the used characters. So we can of course just represent them with a string, right? Just pass a string. But then it would be a little bit hard to check that a new string, let's say if we had A, D, E, B, C, E, something like this, and then we have a new string XL, for example. Checking that it has no duplicates with this would be just check each character, right? That's certainly possible, we can do that, but an easier way to do that is with Python set. So if we use set in Python, then we can just say whether set 1 and set 2, like this, we can check the length. If it's equal to 0, would mean that there is no duplicate element between set 1 and set 2, right? So that makes it really easy to check this, and then combining both would be to get a new set that has both set 1 and set 2 in it, right? Would be just doing set 1 or set 2, and that would make a new set called set 1 that has both at the same time, right? And so with this, the two operations that we need, which are checking that we asked here, which is checking that the new string doesn't have duplicate characters with the used, we can do that by just making the new string a set and checking if we end it with the used so far. If the length is 0, that means there is no element common between the two. That means we don't have any duplicates. So it's a really easy operation. And then to union them, we can just use this. And so we would just need to say that set of the new string that we are using with the used so far, right? So this makes it really simple, straightforward to use. In other languages that don't have this functionality with set, you can achieve the same functionality with bits, because we have only lowercase letters, and so we have 26 characters only, right? So that would mean that we could just use 32-bit integer, right? Because 26 characters would fit into that. And with bits, these operations or and end also are possible, right? And so that's pretty much it. So now let's code this up in a clean way and see if it passes Leetcode checker. Okay, so let's code this solution now. So as we said, the base case is just so the base case is if sorry about this. So the base case is just when the length of the array, the index. So first, let's just define the recursive function that we will be calling next. And so first we need to define our recursive function. Let's just call it recursive like this, and the parameter that changes is the index, and we need the representation of the used characters so far, which will be a set in our case, and that function would be called here, and we will start out with an empty set, right? We haven't used any characters, and we are starting at the first position, right? And then the base case is when we are at the end of the array. In that case, we can just return 0. There is nothing else. And then we have the two choices. So the first choice is leave it, which is leave the string, and that would mean just calling this recursive function with the same characters used so far, since we are not going to use the string, and then just go to the next position. Or the other choice is take it if possible, or if it's valid, right? So the first part of being valid is that let's just say S is the string that so that we don't type array index every time. So it is valid if itself doesn't have any duplicates. If itself it's not something like AB or maybe CAC, for example. These are not valid, so we want to eliminate those. And so to check if a string doesn't contain duplicate characters, we can check just that its length is equal to the length of itself as a set, because a set of, if you do a set for this here, that would be just AB. So the length would be 2, however the length of the string would be 3, and this would be different, and so we'll consider it not valid, right? The other part is checking if it's valid with the used character so far, which means basically there is no duplicate characters between it and the used so far. So valid with used so far, and that would be just checking that if we combine the used so far with the set itself, then maybe I should just say like this, put this value so that I don't repeat it multiple times. Okay, and then so if this combining the two set and the length, as we said in the explanation, if the length is 0, that means there is no element in common between them. That means there is no duplicate characters between the characters we took so far and the new string. And so if both are valid, that means we can take this string, right? And taking this string would mean, so let's just put the maximum length, because we want to take the max of the two choices, right? And so the maximum length would be the max of the two choices, so the previous choice and the new choice, and the new choice is just recursing on, we are taking the string, so that would mean we need to do used. And as you said, if you remember, I said that to combine the two, we need to use OR, right? And so the new thing that we used is this. So actually it's just set, right? It's just set of the string, right? So combining them would be just like this. However, this max length here, we need to add the string, the length of the string, because we are taking it. So we need to count the length of the string as part of the length. And then we need to go to the next character or the next string in the array. So now that we made the two choices, we took the max, we can just return the maximum length. That's pretty much all there is to this solution. Okay, so now let's run this and see if it passes. Okay, so I think I need to just put this in parentheses. Yeah, in Python this should be end. Okay, let's submit. Okay, so that solution passes. Next, we will see how to change this slightly to be a dynamic programming solution. Okay, so now let's see how can we make this a recursive, make this into a dynamic programming solution. So we know that the gist of it is just having two choices. Taking the string or not taking it. If it's taking the string only if it satisfies the constraints, right? And so what is the DP state then that we will be using? And first, before saying the DP state, let's first just look at the goal of the function, right? So the goal is just to return literally what the problem says, the maximum length of concatenated string with unique characters ending at the last position, right? Because we want for the entire array. And so our DP state would be just this, just for a sub problem, right? So our DP state is just maximum, so exactly almost the same thing, length of a concatenated string with unique characters, but ending at I, so that we can have a sub-problem, right? Okay, so now let's see what is our DP state. So for DP of at some position I, we wanna take all the used string in the previous DP states, let's call them used, and we want to, so for all used in, right? And then what we want to do is check if that's valid. Actually, let me just write this differently. So first we want to do the DP, we want to just go through the array, element by element, the string, and first check if the string itself has duplicates, right? Because at that point, if it has duplicates, then we shouldn't even consider it, right? So that's the same thing. So if the length of the set is less than the length of the string, then just continue. We don't want to even look at it. Otherwise, let's say that the string set, the same way we did in the solution before, that's just set of A. And the way we are going to use this is that we are going to look at all the strings that we used so far, right? All the possible concatenations that are valid that we used so far, which we will store in our DP array. So we initialize our DP array with first we have used nothing. So this is almost the same as the recursive solution, right? We start out with an empty set. And then we will go through all the previous ones that we used. And then we will check if taking this string is possible, right? If it's valid to take the string. And that we would just do it with checking the length of what we used before and this set in the same way as we used in the recursive solution. If that equals to 0, that means there are no duplicate values between them, right? And so at that point, we can add this string into the set of possible solution, right? Because it's a valid concatenation. And so to add them two sets together, we use the OR operator in the same way that we used in the previous solution, which is set 1 and set 2, get a combination of the two. And the two are just used and, it's OR SS, which is the set of for A, right? And then after that, we will just return the max of all of them. So DP here contains the max, it contains the so actually my DP here wouldn't contain this. It would contain all the sorry about that mistake. So it will contain all the string concatenated from that have unique characters, right? And then from these, I could just take the maximum, the one with the maximum length, because they all are satisfy the condition, the constraint. So at the end, I could just return the maximum one and the length of the maximum one, right? So that's what I want. So the length of the max of DP, and since what's in DP array is the strings, I will need to do it by key length. This in Python means just compare all the content of DP using the length and return me the one in maximum one in terms of this criteria, and so I will get the longest string and then I'll take its length. There is a slight thing that I need to change, which is since I'm appending here to the DP array and not like assigning an index like we usually do with DP, I will need to put a copy here, and this is how we copy in Python, just so that if I append one, and I already did this, that means I will just append one, and then I will do again for that one. So this would be like an infinite loop, because I just add and then consider it, and then maybe add another one and consider it. So that's why I just take a copy here. So this here is equivalent to just doing copy of dp, right? Okay, so that's the dynamic programming solution. Now let's code it up into Leetcode and see if it passes. Okay, so I just copied the exact solution that we just saw in the explanation here, and let's just run it and see if it passes. Okay, so that solution also passes. Yeah, so that's it for this problem. Thanks for watching, and see you next time. Bye.